In this video, we're going to look at systems of nonlinear equations and inequalities with two variables. So we're going to start with a warm-up here, where we have done these in previous sections. I'm going to go ahead and take this equation and make all the x's go to one side of the inequality and all non-x's. And subtract x from both sides and add 3. So I have x is greater than 8. Now, as a solution, we would write this as a parenthesis 8 comma infinity, or that's interval notation. Set builder notation would be curly bracket x straight line, which means such that x is greater than 8, and then in that curly bracket. Graphically, what this is here is 0 and here is 8, is I'd have an open parenthesis, which means it doesn't include it, and then I would shade on the number line. Now, if I look at b, the difference between a and b is now we have a squared. So since it's squared, I need to bring everything to one side of the equation and 0 on the other of the inequality. So I'm going to have x squared minus 4x minus 5 is greater than 0. And I have x minus 5, x plus 1 is greater than 0. And I can either do a sign chart, or I can draw the graph. The graph of the quadratic. The graph of the quadratic would mean that we cross at -1 and we cross at 5. Here's what the graph would look like on the xy plane. And, excuse me, I want to know where it's strictly greater than 0, where it's strictly greater than 0 in this part and this part of the graph. So it would be from -infinity to -1, union between 5 to infinity. There it is in interval notation. In set builder, you would have x such that x is less than -1 or x is greater than 5. Okay, on the next one, if I do a sign chart to solve this, I would have x minus 3, x plus 4, the quantity squared, x minus 1. And then I have to make sure that I have all of my zeros in order. This first one produces x is equal to 0. This is 3. This is -4. This is 1. So my first one would be when x is equal to -4, when x is equal to 0, when x is equal to 1, and when x is equal to 3. So I choose something in this interval. So I'm going to choose x is equal to -5, negative, negative, positive. This is positive all the way across because of the fact it's squared. And this is negative. And so I end up with a negative. I put positive. I end up with a negative for that interval. So this is going to be a negative for that interval. I'm going to choose something between -4 and 0. So I'll choose -1. This is negative, negative, negative. Again, this is a negative right here. I'm going to choose something between 0 and 1, so I'm going to choose 1/2. This is positive, this is negative, this is negative, so this region is positive. This region is positive. I'm going to choose something between 1 and 3, which is I'll choose 2. Positive, negative, positive. This region is negative. And then I'll do the last one where x is equal to, we'll do 4. So we get positive, positive, positive. So this region is positive. Now we also know that we could have drawn this shape, and I would have a -4 there. And then I would have had 0 and 1 and 3. The degree of this polynomial, there's going to be an x times another x, so that's x squared, times 2 more x squareds, so that's x to the 4th, and then times another x, which gives me x to the 5th. Leading coefficient's positive, and so it's going to look something like this. And we know it would have bounced at the -4 because its multiplicity was 2. Now, whether I did a sketch of the graph or I did a sign chart, it does not matter. I'm looking for this is less than 0, where it's less than 0 here, it's less than 0 here, and it's less than 0 here. And we get equality. Because we have equality, then I'm going to have from negative infinity to 0 inclusive. And then I'm going to go from 1 to 3. 1, 2, 3, and these are inclusive. Now, had this been less than, strictly less than 0, so say I would have had this polynomial, which is strictly less than 0, then that would have been different. Then its interval would have been from negative infinity to negative 4, union from negative 4 to 0, union between 1 and 3. And I'll let you think about why it would be if that was strictly less than 0. Okay, just like linear systems, nonlinear systems may or may not have a point of intersection, but unlike linear systems, nonlinear systems cannot be solved by, usually by elimination. Sometimes they can, but they definitely can't be solved by matrices. And you're like, what's a matrix? Well, we're going to talk about that in the next one. And they may intersect in more than one point. So if I was graphing a circle and a line, I can have the circle and the line not touch at all. I can have the circle and the line touch once, or I can have the circle and the line touch twice. So sometimes we're going to solve by substitution, and occasionally we can solve by elimination, but not necessarily. If I had two parabolas, again, I could have two parabolas that are shaped like this, and neither they touch not at all. I can have two parabolas that touch only once, and that's at the vertex. I can have two parabolas that are like this, and they can touch twice. I can have two parabolas that only touch once, actually can touch twice. So with parabolas, we have a lot of possible ways in which we can have solutions. It's not just a single point. The same thing when we have parabolas and circles or two circles. So if we're asked to solve these, I cannot do elimination. Like I can't multiply this by an x, because if I multiply this second equation by an x, I'm going to have an xy term, which I don't have up here to eliminate. So what I have to do is I have to do a substitution. So I'm going to do y is equal to x plus 1, and I'm going to substitute it into the second equation. So I'm going to have x squared plus x plus 1, that's my substitution for y, is equal to 25. So I'm going to get x squared plus 2x plus 1 is equal to 25. So I'm going to get 2x squared plus 2x, subtract 25, so I get minus 24 is equal to 0. I'm going to divide everything by 2, just make it easier to factor. So I'm going to get x squared plus x minus 12 is equal to 0. And so x minus 3 and x plus 4 are the two factors. So x is equal to 3 and x is equal to negative 4. That means I'm going to have two y values. So I'm going to start with the first one when x is equal to 3. I'm going to have y is equal to 3 plus 1. And so my first ordered pair is 3, 4. And then I have when x is equal to negative 4, I'm going to have y is equal to negative 4 plus 1. So I'm going to have negative 4, negative 3. So I have 2 points of intersection, and I kind of expected that because this is a circle centered at the origin with a radius of 5, and this is a line. Take a look at this example. These are actually two equations where I can do elimination. And not only that, but this is a circle centered at the origin, and this is a parabola on its side. So I'm going to do elimination. What I'm going to do is I'm going to take and multiply the second equation by a negative 1, and that's going to give me x squared plus y squared is equal to 25. Negative y squared is equal to negative x minus 5. These cancel. I get x squared is equal to negative x plus 20. I'm going to bring everything to one side, and so I'm going to get x squared plus x minus 20 is equal to 0. And so I get x minus 4, x plus 5 is equal to 0. So I'm going to get x is equal to 4 and negative 5. Okay. Now I have to put this into one of the two equations. I'll put it into this equation because I've already got y equals. So when x is equal to 4, I'm going to have y squared is equal to 4 plus 5. So I'm going to get y squared is equal to 9. So y is equal to plus and minus. Don't forget the plus and minus, the square root of 9. So y is equal to plus and minus 3. Oh, so I'm going to have 4 comma 3, and I'm also going to get 4 comma negative 3. That's a good time. And now I'm going to do y is equal to negative 5. And I have y squared minus is equal to negative 5 plus 5. So y squared is equal to 0. So y is equal to 0. So I have negative 5 comma 0. So this thing actually has 3 points of intersection. Here as I have, this is a circle centered at the origin, and this is an ellipse centered at the origin. And either we're going to have no solution, we could have one solution, we could have 2 solutions, or we could have 4 solutions. Again, I can actually do elimination on this. So I'm going to take this first equation and I'm going to multiply by a negative 9. I got negative 9x squared minus 9y is equal to negative 36. 16x squared plus 9y, and that should be squared, is equal to 144. So negative 9 and 16, positive 16 gives you a positive 7x squared. Those go to 0. And I will need my calculator out because I don't feel well enough to actually do the 144 in my head. Even if I did feel it well enough, I'm not sure if I could have correctly. Anyways, I get 108. So x squared is equal to, I'm going to divide that by 7, and I get 108 divided by 7. And it doesn't actually give me a very nice number, which happens sometimes. And so I'm going to get x is equal to positive and negative square root of 108 over 7. I wonder if 108 is not divisible by 7, so that's as good as it gets. That's unfortunate. Okay, so now I'm going to take this equation right here. I'm going to say y squared is equal to x squared plus 4. So y squared is going to be equal to 108 over 7 plus 4, because x squared would be 108 over 7. And coming up here, we get y squared is equal to 108 over 7 plus 28 over 7. And I end up with y squared is equal to 136 over 7. So y is equal to positive and negative 136 over 7. Okay, so how does this solution work? Well, with this solution, I have to get first the positive. I'll do this positive square root of 108 over 7 for the x, and I'll take the positive 136 over 7 for the y. And then I'm going to do the positive 108 over 7, and then I'm going to choose the negative 136 over 7, the square root. And then I'm going to do the negative square root of 108 over 7 with the positive 136 over 7. And I'm going to do my last one, which is the negative square root of 108 over 7, and now the negative 136 over 7. Algebraically, we found a solution, right? Show you where they intersect. However, when you go back and check this into the original equations, they don't check. So you can get solutions algebraically, but they don't check in the original problem. Now remember, we had x squared plus y squared is equal to 4. So I'm going to go ahead and put in one of the 108 over 7, the quantity squared, and one of the y's. Square root of 136 over 7, the quantity squared. This does not equal 4 because I have 108 plus 136 all over 7 are not going to equal 4. So algebraically, we can find solutions, but these are ones that we do need to check. So this is a no solution. just as an FYI. So in other words, it is the empty set that way or the empty set that way, because all of these solutions that we thought we found were extraneous. So just be aware we still have extraneous, and so you really should be checking this. And I didn't on the other ones. I should have checked on the other ones. Okay, so now let's go ahead and do this one. I'm going to multiply this by a -2, this last example. So I have -2xy minus y squared is equal to plus 2y squared is equal to -4, and 2xy minus 3y squared is equal to 0. Add these two together, I get -y squared is equal to -4. Y squared is equal to +4. Y is equal to positive and -2. So I'm going to have to put that into one of the two equations. I'll put in the first one. So I'm going to have x multiplied by a +2 when x is equal to +2. And then minus the +2 squared is equal to 2. So I have 2x minus 4 is equal to 2. And so I have, what am I doing? 2x is equal to 6, x is equal to 3. So my first ordered pair is going to be, and this is y is equal to 2. My first ordered pair is 3, 2, and I am actually going to check it. I'm going to check it into the second equation. If I put into 2 times 3, that's my x, this is my x times y, minus 3 times my y, which is 3 squared, does this equal 0? And so I'm going to have, and this should be 2 squared, not 3 squared. Man, I'm not feeling well. Sketchy as crap. This is 4 times 3, which is 12, minus 12. Yes, it does indeed equal 0. So we know that this is a true solution, at least one of them. Now we're going to do y is equal to -2. So I'm going to do x multiplied by the -2 minus the -2 squared is equal to 2. So I have -2x minus 4 is equal to 2. So -2x is equal to +6. So x is equal to -3. And I'm going to check it in the second equation. So 2 multiplied by -3 multiplied by the -2 minus 3 multiplied by the -2, the quantity squared. Does this actually equal 0? And I'm going to get +12 minus 12 is equal to 0. So that does check. So -3, -2 is also an answer. I don't know what I'm doing there. Let me just try that again because that was terrible. So -3, -2 is also a solution. Okay, when we are graphing systems of inequalities, we're either going to have dashed lines or solid lines, depends on whether or not my inequality is inclusive or non-inclusive. Solid lines, and we'll use a solid line, we have greater than or equal to or less than equal to, and dashed lines when we have strictly less than or strictly greater than. So here's the how-to, and we're going ahead and graph this. And by the way, and this is a circle where I have x squared plus y squared is equal to r squared. This is a circle centered at the origin with a radius of, in this case happens to be 16. So I'm going to go ahead and draw the graph of this circle poorly, because I can't draw circles. And radius is not 16, it's 4. It's 4. So I'm going to zoom in and I'm going to go out 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to draw this lovely, almost a circle. Almost a circle. Now, what I do is I choose a test point inside and outside of the circle. So I'm going to test I'm going to choose a test point. I'm going to use 0, 0. Okay, so 0 squared plus 0 squared, is that less than or equal to 16? If the answer is true, I'm going to shade inside that circle. If the answer is false, and I shade on the other side of that circle. In other words, outside the circle. It's true, so I shade toward it. So then I'm just going to have this. This is the line y is equal to x, but it is a dash line, and so I'm going to do a dash line because it's non-inclusive. So here's my dash line, and I'm going to choose a test point. So I'm going to test. Let's choose, I can't use 0, 0, so let's do 1, 0. 1, 0 is right here. So is 0 less than 1? Since this is true, I'm going to shade toward my test point, from the line toward my test point. Now my solution is this part of the graph in which they're both shaded, so I'm shading this in green. Okay, so that's the solution when we're doing inequalities. Once again, this is a circle centered at 0, 0, whose radius is 9. So I'm going to come over here, and I'm going to draw my circle with a radius. Gosh darn it. Oh, darn it. Radius of 3. 3. Told you I'm sketchy. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I'm going to draw the best circle I possibly can, which that's about as good as it gets. I'm going to choose a test point. So again, I'm going to test 0, 0. Is 0 squared plus 0 squared greater than or equal to 9? This is false. Here's my point, and instead of shading inside the circle, I'm going to shade outside the circle because it was a false statement. So I'm shading outside of the circle. And I'm going to have x minus 3 is greater than y. So all I did was make it so that it is of the form y is equal to mx plus b. That just makes it easier for me to graph. So I added y to both sides and subtracted 3. So I know I'm going to go through negative 3 right here. I'm going to have a slope of 1. So I'm going to also go through this point. It is a strictly less than, and so I'm going to use a dash line. So here's my dash line. I'm going to choose a test point. So I'm going to test 0, 0. I'm going to go back to the original one, which is 0 minus 0 is greater than 3. This also is false. So I'm going to shade on the other side of my test point. And my solution is this shading in green. It's going to be outside the circle, but below that line. So that's my solution. There's the shaded green region. Okay, so this next one we know is a parabola. It is actually one of the toolkit parabolas. So I'm going to come over here and draw that. So it's going to go through 1, 1, 2, 4. And it's going to look something like this. It's a terrible parabola. And it is a solid line because we have inclusive. Now here's an equation of the form y is equal to mx plus b, and I put 2. So it's going to go through 2. It's going to have a slope of 1, and it's a dash line. So here's my dash line. Oh, I should probably do a couple of test points. So let's test the first one. Now I can't use 0, 0, so I'm going to test 1, 0. 1, 0. Where is that? 1, 0 is right here. So I'm going to test whether or not 0 is greater than or equal to 1. This is false. So I'm going to shade inside the parabola because that first one is false. Now I'm going to test for here. I can use 0, 0, so I'm going to test using 0, 0. And so 0 is less than 0 plus 2. This is true. So here's my point, and that was my test point, and I'm going to shade in this direction. And so inside of the parabola, but below that line in the shaded green, is my solution. So we know that this is of the form y is equal to 1 minus x squared, which is of the form of negative x squared plus 1, which means it's a transformation of our parent function in which I have moved up 1 and reflected over the x-axis. So I'm going to go like this, here and here. So that's what that looks like. And then this is of the form y is equal to mx plus b. So I'm going to go down to -1. And this was inclusive and this was not. So I'm going to do the line with a slope of 1. It's a dashed line. And by the way, I just want to say that these other shapes could be dashed. So if this was inequality, which we didn't have equals, I would just dash this parabola. So I can have a dashed parabola too. Just for whatever reason, the examples I chose did not have that. So let me go ahead and fill that back in. And for both of these, I'm going to test 0, 0. So this first one, I'm going to test 0, 0. And is 0 greater than or equal to 1 minus 0? This is true. UE. Here's my test point. I'm going to shade toward my test point. So I'm shading inside of my parabola. And then I'm going to test 0, 0 on the other one, the other inequality. So is 0 greater than 0 minus 1? 0 is greater than -1. This is also true. So I'm going to shade toward my test point. And then again, my solution is in green. Okay. Here's some questions to ponder. When you graph a system of inequalities, will it always be a feasible region? If so, explain why. If not, give an example of a graph of inequality does not have a feasible region. And the answer is, yeah, you can. So say you've got two parallel lines. Y is equal to 3x plus 1. I'm going to do greater than. And then you have y is less than 3x minus 1. And in this case, they're going to be two lines that are dashed. The first line is going to be shaded up. The second line is going to be shaded down. And these two aren't ever going to have any place in which they're both shaded. So you're not going to have a solution. So if you graph a revenue and a cost function, how would you determine the regions where there is profit? Well, the revenue function, revenue of x, has to be greater than the cost function. If the revenue isn't bigger than the cost function, then there is no way to make any money because the profit function is equal to the revenue function minus the cost function. Now, if this ends up being a negative number, then obviously your revenue, you're not making enough revenue. So let's set this one up. Negative 3x squared plus 480 has to be greater than or equal to is a break even. But if we want to make money, then it is strictly greater than. And I'm going to have 8x squared minus 600x plus 2150. I'm going to bring everything to the right, so I have 0 is greater than. I'm going to add 3 and 8, so it's 11x squared minus 600x, and then plus 21, and I'm subtracting 480, so 21,020. Now I'm going to throw this into a quadratic equation, so x is equal to 600 plus or minus the square root of 600, negative 600 squared, so it just says 600 squared, minus 4 multiplied by 11 multiplied by 2120, all divided by 2 times 11. Now, when I put in my calculator the 600 squared, that's terrible, let me draw this again. The 600 squared minus 4 times 11 multiplied by 21,020. I don't know what this is doing over here. So 20. This is less than 0, which means I have complex numbers, which means at this moment you can never make a profit. That's not going to happen. because my discriminant, or the value underneath the square root, is negative, which is complex, which means there's no way that I can ever get a profit. And that's it for this video.